Hmm. Trigonometry, Chapter 1, Trigonometric Functions, Section 4, Using Definitions of Trig Functions, Video 10, Quotient Identities. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we discussed the Pythagorean identities. Here they are. You need to memorize these. Cosine squared theta plus sine squared theta equals 1. 1 plus tangent squared theta equals secant squared theta, and cotangent squared theta plus 1 equals cosecant squared theta. I haven't mentioned it previously, but the actual variable is irrelevant. It doesn't matter if the variable is theta, alpha, beta, x, y, or even a constant like, I don't know, 37.5. As long as the equation has the structure, it's going to be valid. And before that, we discussed the reciprocal identities, and you need to memorize these too. You should know them by now. In this video, we will explore a third type, quotient identities, quotient being the answer to a division problem. And if you're wondering how many types of trig identities there are, the answer is many more. We will explore other kinds later. For now, focus on reciprocal, Pythagorean, and quotient. A quotient identity addresses the ratio of two trig functions, specifically when the ratio of two trig functions equals a third trig function. We will start with what is by far the most common and arguably the most important quotient identity, the ratio of sine to cosine. In other words, if we put sine of theta over cosine of theta, what does that equal to? The most straightforward way to simplify this ratio is to replace each trig function with its definition's ratio. So sine of theta is y over r, cosine of theta is x over r. And then we just clean this mess up. Every fraction is a division problem, so we can write it as y over r divided by x over r. But then we multiply by the reciprocal, so it becomes y over r times r over x. And if you notice, the r's are going to cancel, so cancel the r's and multiply, and we're left with y over x. But the ratio of y over x, that's just tangent. And we have our first quotient identity. Sine of theta over cosine of theta equals tangent of theta. Memorize this right now. Sine over cosine equals tangent. I'm not kidding. Now, this is far from the only quotient identity, but as I mentioned earlier, this is the most important one to memorize, in my opinion. But are there others? Well, with 6 trig functions, there are 30 possible ratios. Well, 36, because 6 choices for the top, 6 choices for the bottom. But 6 of those ratios compare a function to itself, like cosine over cosine. Don't mess with that one. One immediate such ratio is formed by reciprocating both sides of your first quotient identity, the one in yellow. Can you picture what it will look like if we reciprocate both sides? What does the reciprocal of this fraction look like? That's easy. But what's the reciprocal of tangent? Can you picture what it'll look like? Is this what you pictured? Cosine of theta over sine of theta equals cotangent of theta? In most books, this is listed as the other quotient identity. There are more than 2, but this is usually the 2 that they give us. But I'm a big advocate of memorizing this one. Sine over cosine equals tangent. And then deriving the other one as the reciprocal of the first. You see, trying to memorize both of them often leads to getting them mixed up, because there doesn't seem to be a rhyme or reason unless you go through the proof of which one is equal to which. I know both of them, but I memorized the first and I understood how to convert it into the second. So please, please, please memorize this one. I cannot stress this enough. And then just reciprocate it if you want the other one. I invite you to discover the other quotient identities. There are 8 of them, and they occur in reciprocal pairs. I'll give you a hint. The first one, sine theta over cosine theta, worked because one of the variables eventually canceled. Remember? Right there, the r's canceled. So the other ones hinge on something canceling at the end. Now you try. Pause the video and try the following. Okay, these aren't officially quotient identities, but each simplifies to one trig function. See if you can find it. Okay, here comes your fair warning. If you haven't paused the video yet, solutions in 3, 2, 1.